Hello, you are most welcome. I'm teacher Ivan from Wunna Educational Services. I welcome you to this particular lesson where we shall be looking at the physics calculations and our today's coverage will be on relative density. Relative density is defined as the ratio of density of a substance to density of equal volume of water. And from that definition is where we get the formula for relative density, which is density of a substance over density of equal volume of water. But still, relative density can be defined in two other ways, and these are: we can define relative density in form of mass, whereby it will be defined as the ratio of mass of a substance to the mass of equal volume of water. And from that definition is where we shall have our second formula of relative density, which is mass of a substance over mass of equal volume of water. Still, we can also define relative density in form of weight, whereby relative density is defined as the ratio of weight of a substance to the weight of equal volume of water. And therefore, from that definition, we also have our third formula for relative density, which is weight of a substance over weight of equal volume of water. So these are the three formula that we needed to know as we are looking at the relative density calculations. However, it is also very important to note that relative density has no units, simply because it is a ratio of the same quantities. Let's assume weight of substance is in newtons, still over weight of equal volume of water, which is also in newtons. So the newtons will cancel out. Similarly, the same applies to mass. Kilograms over kilograms, which cancels out. The same applies to density. That's why we have it with no units. So we are now going to our examples, but before we go for examples, please, I kindly request you to first of all subscribe to our YouTube channels. Starting with this, we also have more channels. You can go to featured page, featured channels. They are all our channels. Subscribe to them. However, you can also just scroll down on our homepage of this channel. You find those channels. Subscribe to them so that we learn together as we enjoy together. We also have TikTok accounts in the names of Wunna Educational Services, Wunna Kids Platform, Teacher Ivan's online class, Learn Physics with Wunna, Learn English with Baby, Learn Mathematics with Baby. We have Wunna Movie Center, we have Wunna Lyrics, we have The Soul Entertainer. Those are all our TikTok accounts where important information is brought to us. We also have Facebook pages and groups in the names of Wuuna Educational Services, that is a page. We have Wuuna Math Channel, which is a page. We have Wuuna Education Initiative, a page. We have Mathematics and English Discussion, a page. We have Mathematics and Physics class. We have Wuuna e-learning platform. We have Wuuna Kids platform. We have Teacher Ivan's online class. Among others, we have very many pages and groups on YouTube where we provide various educational services in various disciplines of learning. So please search for Wuuna Educational Services on any platform and join our academic platforms so that we learn together. Otherwise, let's continue to examples. However, these examples are on two things. We shall look at relative density of liquids and that of solids. Let us start with relative density of liquids. We are using a density bottle or a container, whereby the relative density will be mass of the liquid over mass of equal volume of water. So that means that if we are using a density bottle, then it is keeping the volume constant for both the liquids and the water. And therefore, that gives us the relative density as M2 minus M0 over M1 minus M0, where M2 will be the mass of the container or the density bottle full of liquid. M1 will be the mass of the container or density bottle full of water, and M0 will be the mass of the empty container or density bottle. Meaning that if we get M2 minus M0, we are getting the mass of the liquid, because this is mass of liquid plus the bottle minus mass of empty bottle, which gives us mass of the liquid. Then M1 minus M0 gives us mass of water, whereby M1 is mass of bottle full of water and M0 is mass of empty bottle. So that's how we use the density bottle to get relative density of liquids. For instance, we have an example on that. We are given a density bottle was used to measure the density of mercury, and the following measurements were taken. 1, mass of empty bottle, which was 20 grams. We have mass of bottle full of mercury, which is 360 grams. We have mass of bottle full of water, which is 45 grams. And therefore, the question is, they want us to get the relative density of mercury and the density of mercury. Don't forget that the relative density is given as the mass of mercury over mass of water in this case. So we shall say that our relative density RD equals to mass of mercury over mass of equal volume of water. And now, since we are using the same container, which is a density bottle, the volumes are equal. Therefore, This is given to us as the mass of bottle full of mature, which is 360 grams. Take away the mass of empty bottle, which is 20 grams, over mass of bottle full of water, which is 45 grams. Take away the mass of empty bottle, which is 20 grams. And therefore, this gives us 340 grams over 25 grams. The grams will cancel out, and whatever we shall get will be the relative density of mature. And then, that is question 1. But we also have question 2, which requires us to get the density of mature. Therefore, remember we have 3 formula for relative density, whereby relative density equals to density of mature in this case over density of water. And that means that to get the density of mature, we shall now cross multiply, whereby density of mature will be the relative density times density of water. The relative density is what we have just gotten, which was 340 over 25 times the density of water, which is 1,000 kilograms per cubic meter. Or we can use 1 gram per cubic centimeter. And therefore, when we divide this by 25, 1 by 25 is 40. So we multiply to get the density of mature. That is how we shall get the density of mature. And that is when considering the density, the relative density of liquids using a density bottle. Then our second part is when we are considering the relative density of solids. Here we shall use an idea from Archimedes' principle. And therefore, this is one of the applications of Archimedes' principle, determining relative density of a solid, whereby it is given as weight in air over apparent loss in weight of the solid in water, or what we can term to as upthrust. And therefore, the weight of the solid in air is WA minus, divided by the upthrust, which is the apparent loss in weight, whereby this is weight in air minus weight in water. So that is how we get the relative density of a solid using Archimedes' principle. That is weight in air over upthrust, where upthrust is weight in air minus weight in water. And therefore, as we are summarizing, we must take our assignment. So there are 2 numbers here as your trial question is. That is number 1. Please try it out and see if at all you have achieved or acquired the knowledge on how we use the density bottle and how we use Archimedes' principle in calculating relative density of liquid and solid respectively. That is our second number 2. So please don't forget to subscribe to our YouTube channels, starting with this one. Subscribe, like, comment, so that we may know how we are serving you and how to improve. Don't forget to share with classmates and other members who may want to use the same knowledge. We are on YouTube, we are on TikTok, we are on Facebook. Please search for Wunna Educational Services.